All right, guys. In this video, we are going to start off a little bit different. Uh, we're going to first kind of do a little bit of some discovery here on Desmos with how some of this polar graphing works. It's just, it's one of those things that's a little bit challenging to demonstrate by hand. And so I just got a polar graph on here for us to look at together, okay? So anyways, our graph that I have on here for us, let me get this to a whole value maybe, if it will let me. All right. So anyways, this graph that I've got for us, we see ourselves a little limacon situation. I can never say the word the right way, but we have that type of polar graph right now. And in this case right now, the B value is more than the A, so we see this little loop. Now, what I wanted to do is kind of show you how these things are built as theta goes from 0 to 2 pi. The period of sine and cosine just naturally is 2 pi. So unless something has happened to adjust the period of that function, then it takes 2 pi to complete the whole figure. So I'm going to show you really quick how this thing is built from the beginning. And what I've done is I created just that parent function here. I put a plus b sine theta, and I'm having this go from where theta is 0 to n, and I've got a slider. And what we're going to do is we're just going to kind of see how this grows, okay? So what I want you to see, first of all, is where it starts. As we kind of start out, it doesn't start from the origin as you would expect. It does start over here where that 2 is on that horizontal axis. So you see it starting there, and it grows and grows and grows and grows and grows and grows until it reaches that max point. Now remember, that max point is the sum of A and B. So 2 plus 3 is 5, and that's where you can see this is hitting out here on that vertical axis. Okay, then we keep going, and it starts dropping back down, and then we see it hit that that horizontal axis again. All right, and then we're going to see this thing drop below, go through the origin, and then this is where the loop-de-loop happens. So the loop-de-loop is towards the end of the life of this function, or the life of the period there, and then it circles back around and then hits where it started. So you can see that little growth pattern. If I play the slider, you can just see it growing, and then you'll see it disappear again, going backwards. Yeah. Okay, so just so you've got an idea of where this thing comes from, that's kind of what the purpose was for that. So we've done some graphing with these types of figures before, but, this one, I just thought it didn't hurt us to see it in Desmos. The other thing is I want to talk about equating this to rectangular, which I know sounds a little bit wild, but we have graphed things in rectangular before, right? Like if I was going to take the exact same function and then I were to graph this on that rectangular grid, then you see this, okay? I've got the exact same stuff, except I have it in terms of X and Y instead of R and theta, right? So you can see that right there. And as you make, now this one, I don't have the domain set, but so I'm not going to watch this thing like grow and shrink, but you can see how that looks rectangular, right? We have that wave pattern. Remember, sine starts on the midline on that vertical axis, and then it goes up and then down. And so anyways, just normally we start at the origin, but you want to really think about the fact if this has been moved up, which is what the A signifies, then it's starting from that point on that vertical axis, and it goes up and then down. And if B had been negative, right, it would have opened down instead. So it would have started at that 2, opened down. Okay, so this is going to come back into play today because I want to see if we can understand how these things correlate to each other. So I'm going to put this back in polar. You're going to see our wave is still on here, but I want you guys to see this stuff side by side. And really, maybe I can put a domain on here for this. let's make our domain go. I don't have that key. Okay, here we go. We're going to make our domain try to match that of the, this is kind of just on the fly. Anyways, okay, so that's just that from 0 to that 2 pi, or that n value here. Okay, I'm going to turn this other one on, and I want you to see how these compare to each other. Okay, now at first glance, you may not notice much that they have in common, but I want you to look at it a little bit and see if you start recognizing anything, okay? Now, it makes it a little bit harder because I don't have it fully in rectangular form, but I want you to see how high this thing goes right here. You see how that maximum height, we're seeing that matches what the maximum height was for that other one. Let me show this back in rectangular, and maybe some other things will start popping out at us. Okay, I want you to look. Everything's kind of, it almost looks like it's centered around where that midline was. You see that? It's interesting. Okay. Now I also want you to think about, like, what if we let this thing go from the beginning? So let's let it grow. From the beginning, not much looks like it's in common, but they do hit that same max point right there. And I want you to see what happens here. We're hitting there. And when we got back to the horizontal axis with my polar graph, do you see how my rectangular one hit back at the midline? Okay, so right there, there's some correlation. Okay, when we got 3.14 on my n, that's pi, right? When we got pi around, that hit this axis again, and then my rectangular one hit the midline again, which would have been 2. Okay, keep going. I want us to see what happens here when we hit 0. Not 0, but when you hit, 0 for the polar graph. When you're hitting that origin there for the polar graph, what is the rectangular graph hitting? That's hitting there on the x-axis. So there's some correlation there as well. As my polar graph reaches that origin, my rectangular graph is reaching the horizontal, that x-axis. Okay, now look at this. I think this is really cool to recognize. Do y'all see how this little loop is signifying the part, this little loop in here is signifying the part of the rectangular graph that drops below that x-axis. Isn't that neat? You can kind of just see that, how they relate to each other. And I know it seems a little bit wild to try to compare these side by side, but then look, we drop back around and we end up full circle, and we land back at our midline to complete that whole period. So just comparing how these things work side by side, I think it's important for us to make some of these correlations. Okay, so the way that our video system works, it doesn't like to let me switch back to using my document camera from here. So this was just a quick little video to try to show you some stuff in Desmos, but we are going to switch back to, I've got paper pencil stuff, and so we need to go to the document camera. So this is going to be the end of this little video, but it's not the end of this lesson. So please make sure that you view the next one that goes along with it, where you'll see my paper under the camera, okay? And we'll go through. This is still technically from our textbook, section 5.6, but it's a extension kind of, something that we need to make sure that we cover that we had not got to yet, okay? So it's just kind of an extension of 5.6. I've kind of titled the notes just part B, but we can say part 2. I don't know. That's a little bit disjointed here, but definitely make sure that you watch the next video, okay? And I will see y'all there. All right. Bye. If I can learn how to end it.